On a high-density construction site, every lifted load carries the weight of a dozen variables, from wind shear to ground stability. Physical failures on the ground are often the trailing indicators of critical assumptions left unchecked months earlier, during the design stage. In high-density development zones, the margins for error during heavy lifting are microscopic. Falling objects are a leading cause of site fatalities according to the Workplace Safety and Health Council. Analytical, we measure this through the science of risk, the likelihood of an event occurring multiplied by its severity. Because the severity is fixed, safety efforts must focus on reducing the mathematical likelihood of the event. The traditional safety model relies on site supervisors to manage the physics of a cramped layout in real time. This approach forces personnel to reactively outmaneuver hazards that are already locked into the architectural design. Under Singapore's WSH Act, true safety begins at the blueprint. Downstream management alone cannot compensate for upstream design flaws. By evaluating an engineering layout before work begins, we can identify embedded risks before any machinery arrives on site. This photo details a constrained layout. A crane between active blocks intersects pedestrian routes, risking materials falling into populated zones. Additionally, we see potential for mechanical failure. Without customized foundations for this spacing, crane ground pressure leads to settlement and support failure. Tightly spaced block configurations also introduce environmental hazards by amplifying wind loads, which makes load control increasingly erratic during lifts. Section 27A of the WSH Act requires these risks to be eliminated or minimized specifically at the design stage. Because the spatial layout determines where a hazard exists, the design itself must provide the structural solution. Regulation 4.2 of the WSH Design for Safety Regulations mandates that design risks be reduced at their source. Individual protective measures such as fall arrest systems and standard PPE are at the bottom of the hierarchy. They only activate after a failure has already occurred. Collective protective measures like redesigned spatial layouts and structural guardrails have statutory priority. The goal is to move up the pyramid toward total elimination. When a design forces a crane to lift over active blocks, a worker entering a drop zone becomes a fatal risk. The site practice itself creates the hazard. By optimizing the blueprint to increase block spacing, we eliminate the swing path overlap. Safety is now a function of the geometry, not human behavior. This strategy of elimination aligns with ISO 45001, Clause 8.1.1, regarding upstream risk control during the planning phase. Firmly, downstream barricades and individual personal equipment simply cannot counteract the physics of a site layout that is inherently unsafe. Under the regulations, safety liability begins with the developer, not the main contractor. These legal duties apply to any project involving construction work with a contract sum of $10 million or more. The law mandates the appointment of a Design for Safety Professional, or DSSP, before the detailed design stage begins. The designer then holds a legal obligation to ensure the structure is safe for those who construct, use, maintain, and eventually demolish it. The contractor completes the chain by feeding on-site realities back to the design team and communicating residual risks to site personnel. Failing to appoint a DSSP is a direct breach of Section 27C of the Workplace Safety and Health Act. Legal liability is maintained through this unbroken, documented chain of proactive communication. The industry uses the GUIDE methodology as the operational playbook for conducting these safety reviews. GUIDE stands for Group Stakeholders Together, Understand the Concept, Identify Risks, Design Around Them, and Enter the Results into the Register. As Section 6 of the regulation specifies, the Design for Safety Review meeting is the primary point where stakeholders identify foreseeable risks. Every mitigation must be documented in the DfS register. Section 7 requires this central database to be maintained and updated throughout the project. For instance, the register may document the requirement for barricaded HVAC service ledges, ensuring long-term maintenance can be performed without fall hazards. The DfS register is an active document that absorbs site data and near-miss reports to inform current and future safety decisions. This register transforms static assumptions into dynamic safety intelligence that evolves with the project. To check our understanding, which protective measure holds statutory priority under WSH guidelines? Is it A, individual, or B, collective? The answer is B. Collective measures, like systemic layout changes, take precedence over individual equipment. To execute this correctly, follow the 5 golden rules. 1. Eliminate risk at the drawing board. 2. Prioritize collective protection over individual PPE. 3. Document every residual risk in the DfS register. 4. Remember that projects over $10 million require an appointed DFSP for legal design approval. And 5. Safety is an unbroken chain of accountability extending from the initial project developer all the way to the final demolition contractor. Design for safety is more than a compliance step. It is a choice to ensure